In this session, we are going to see heat transfer by fins. Fins are the surface that extend from an object to increase the rate of heat transfer to or from the environment by increasing convection. The amount of conduction, convection and radiation of an object determines the amount of heat it transfers. Increasing the temperature gradient between the object and the environment, increasing the convective heat transfer coefficient or increasing the surface area of the object increases the heat transfer. Sometimes it is not feasible or economical to change the first two options. The adding of a fin to an object increases the surface area and can sometimes be economical solution for heat transfer. We are going to see what is meant by heat exchanger. A heat exchanger is a system used to transfer of heat between two or more fluids. Heat exchangers are used in both cooling and heating process. Fluid may be separated by a solid wall preventing mixing, or they may be in direct contact. They are widely used in heating, refrigeration, air conditioning, power stations, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and sewage treatment. The classic example of heat exchanger is found in an internal combustion engines in which a circulating fluid known as engine coolant flows through the radiator coils and air flows around the coils, which cools the coolant and heats the incoming air. Another example is a heat sink, which is a passive type heat exchanger that transfers the heat generated by an electronic or a mechanical device to a fluid medium, often air or a liquid coolant. There are three primary classifications of heat exchangers according to their flow arrangement. There are parallel flow heat exchanger, counter flow heat exchanger, and cross flow heat exchanger. In parallel flow heat exchangers, the two fluids enters the exchanger at the same time and travel in parallel to one another to the other side. In counterflow heat exchangers, the fluids enters the exchanger from opposite ends. The counterflow heat exchanger is most efficient in that it can be transferred the most heat from the heat transfer medium per unit mass due to the fact that average temperature difference along any unit length is higher. In cross-flow heat exchanger, fluids travels roughly perpendicular to one another through the heat exchanger.